Mars has fascinated humanity for centuries. It shines in the night sky as a small red star, mysterious and distant. Ancient civilizations associated it with war and fire. Modern science fiction imagined it as a future home for humanity. Cities under glass domes, colonies carved into mountains. A new frontier for civilization. For decades, Mars has been described as the most realistic candidate for human colonization in the solar system. But the truth is far less optimistic, because when scientists examine Mars closely, its environment, its physics, and its long-term stability, one uncomfortable conclusion begins to emerge. Mars may be one of the most hostile places humans could ever try to live. And the deeper we study it, the more it looks like a world that humanity will never truly colonize. At first glance, Mars seems almost inviting compared to other planets. It has a day similar to Earth, about 24 hours and 37 minutes. It has seasons, polar ice caps, clouds, and massive landscapes shaped by ancient water. There are dried river valleys stretching for thousands of kilometers. Gigantic canyons carved into the surface, and volcanoes so large they make Earth's mountains look tiny. The largest volcano in the solar system, Olympus Mons, towers more than 20 kilometers high. 3 times the height of Mount Everest, these features suggest something extraordinary. Mars was not always the frozen desert we see today. Billions of years ago, Mars may have been a very different world. Evidence from orbiters and rovers shows that liquid water once flowed across the planet's surface. Ancient riverbeds, lake basins, and mineral deposits all point to a past where Mars had a thicker atmosphere and a warmer climate. Some scientists believe that early Mars may even have had oceans. If you could travel back for billion years, Mars might have looked surprisingly Earth-like. But something went terribly wrong. Mars lost its atmosphere. And when that happened, the planet began to die. The reason lies deep within the planet itself. Earth is protected by a powerful magnetic field generated by its molten core. This magnetic field acts like a shield, deflecting solar wind as streams of charged particles constantly flowing from the sun. Without that shield, the solar wind slowly strips away a planet's atmosphere. Mars once had a magnetic field, but unlike Earth, Mars is smaller, and its interior cooled much faster. At some point in its early history, the planet's core stopped generating a strong magnetic field. When that happened, the atmosphere of Mars became vulnerable. Over millions of years, solar radiation and solar wind began tearing the atmosphere apart. Gas molecules escaped into space, the pressure dropped, temperatures fell. Water on the surface began to evaporate and freeze. And without a thick atmosphere to trap heat, Mars turned into the frozen desert we see today. Today, the atmosphere on Mars is less than 1% as dense as Earth's. Standing on the surface of Mars would feel similar to standing at an altitude of about 35 kilometers above Earth, far higher than commercial airplanes fly. The air is mostly carbon dioxide, but it is so thin that a human could not breathe it, even with oxygen equipment. Without a pressurized suit, a person exposed to the Martian atmosphere would quickly lose consciousness. Within seconds, bodily fluids would begin to boil due to the low pressure. But thin air is only the beginning of the problem. Mars is also incredibly cold. The average temperature is around -60 degrees Celsius. During winter nights near the poles, temperatures can drop below -120 degrees. Even at the equator during the warmest part of the day, temperatures rarely rise above freezing. For most of the planet, the environment is permanently hostile to liquid water. But perhaps the most dangerous threat on Mars is invisible radiation, because Mars lacks both a thick atmosphere and a global magnetic field. Its surface is constantly bombarded by cosmic radiation and energetic particles from the Sun. On Earth, our atmosphere and magnetic field absorb most of this radiation before it reaches the ground. On Mars, there is almost no protection. Astronauts living on the Martian surface would receive radiation doses far beyond what humans are designed to tolerate. Long-term exposure dramatically increases the risk of cancer, neurological damage, and genetic mutations. Some estimates suggest that a person living on Mars without heavy shielding could exceed safe lifetime radiation limits in less than 2 years. Any realistic Martian settlement would need to be built underground or buried beneath thick layers of soil just to reduce radiation exposure. But even if humans solve the radiation problem, Mars presents another enormous challenge: dust. The surface of Mars is covered in extremely fine dust particles. These particles are smaller than flour and easily lifted into the atmosphere by winds. Occasionally, these winds grow into massive dust storms that engulf the entire planet. Global dust storms can last for months, blocking sunlight and covering everything in a thin layer of static charged powder. For solar-powered systems, this is a nightmare. In 2018, NASA's Opportunity rover stopped working after a massive dust storm covered its solar panels. Even robots struggle to survive these conditions. Human settlements would face constant maintenance challenges. Machinery would degrade, air filters would clog. Solar panels would lose efficiency, and every piece of equipment would need to function in an environment that constantly tries to destroy it. Then there is the problem of gravity. Mars has only 38% of Earth's gravity. That may sound comfortable for astronauts who want to move heavy equipment easily. But the long-term biological effects are deeply concerning. Human bodies evolved in Earth's gravity. Bone density, muscle strength, and cardiovascular systems all depend on it. In microgravity environments like the International Space Station, astronauts lose bone mass and muscle strength rapidly. Even with daily exercise, the human body struggles to adapt. Mars provides more gravity than space stations, but still far less than Earth. No one knows what decades of life in Martian gravity would do to the human body. Children born on Mars might grow up physically unable to survive on Earth. Their bones and muscles could develop differently. Their cardiovascular systems might adapt to lower gravity. A Martian-born human might never be able to visit the planet where their ancestors evolved. Even food presents a major challenge. Mars has no fertile soil as we understand it. Martian regolith contains toxic chemicals called perchlorates. These compounds interfere with human thyroid function and are harmful if ingested. Growing crops would require complex filtration and artificial environments. Every calorie consumed on Mars would require enormous effort to produce. Life support systems would need to recycle water, oxygen, and nutrients almost perfectly. Any failure in these systems could be catastrophic. On Earth, ecosystems provide natural balance. On Mars, every part of the environment would have to be engineered and maintained. And that leads to the most fundamental problem of all: distance. Mars is not just far away, it is extremely far away. Even at the closest approach, traveling to Mars takes about 6 to 9 months with current technology. And those launch windows only occur every 26 months. If something goes wrong on Mars, help cannot arrive quickly. There are no emergency supply missions, no quick evacuation. Colonists on Mars would be completely isolated from Earth for years at a time. This is not like living in Antarctica or on a remote island. It is a different planet. Every piece of equipment, every tool, every medical supply must be transported across tens of millions of kilometers through space. And the cost of doing that is staggering. Some dream of terraforming Mars, transforming it into a warmer planet with oceans and breathable air. But the physics of Mars makes this extremely unlikely. Even if humanity released massive amounts of greenhouse gases to warm the planet, Mars simply does not have enough atmospheric material to create Earth-like conditions. Studies have shown that all the carbon dioxide trapped in Martian rocks and ice would still not produce a thick enough atmosphere. And without a magnetic field, any new atmosphere would slowly be stripped away by solar wind again. Mars is not just a cold desert, it is a planet that lost the conditions necessary for long-term habitability. And it may never get them back. That does not mean humans will never visit Mars. Exploration is almost certain. Robotic missions have already transformed our understanding of the planet. Human explorers may one day walk across its deserts and climb its volcanoes. Temporary research stations could exist there, much like Antarctic bases today. But permanent cities, self-sustaining civilizations. Millions of people living freely on the Martian surface, that vision may remain science fiction. Because Mars is not a second Earth waiting for us, it is a warning. A reminder of how fragile planetary environments can be. A world that may once have had rivers, lakes, and perhaps even life. Now reduced to a frozen desert beneath a thin, dying sky. And the deeper we study Mars, the clearer one truth becomes. Some planets are simply not meant to be homes. If you enjoy exploring the real science behind worlds like Mars and the mysteries of our universe, consider subscribing to the channel and joining us for the next journey into space.